Hello everyone, welcome back to Let's Unbound. Today we are going to learn and practice 1.7 rational functions and its end behavior. So let's get started. Be ready with pen and paper, and also if you have any doubts or queries, you can drop that in comments. Right? Let's get started. So first, what is rational function? The definition. A rational function is a ratio of two polynomials. It will look like P of x by F Q of x. P of x and Q of x have to be polynomials. The function will go undefined. Whenever denominator comes, we are making sure it cannot be 0, right? So yes, we have denominator, so it should not be equal to 0. When it equals 0, at those values, it will become undefined. This is rational function definition. Like it will look like a fractional structure. And end behavior, we know what happens when x tends to negative infinity. What happened to the graph? Either it's moving up or moving down. What is happening to the graph? And when x tends to plus infinity. So both the ends we are considering. This is end behavior. Now, let's see the characteristics, very quick review. And in this particular video, I'm going to cover what is domain, end behavior, and horizontal asymptotes. For vertical and holes, we will have a separate video that's coming up, right? So, okay, domain is all real numbers. Domain means what are the possible input values? Of course, denominator should not be 0. So all real numbers except where the q of x becomes 0. That's it. So exclude that values. And coming to end behavior. So end behavior for rational functions will be determined by the degrees of numerator and denominator. So they have a very simple rule. We will see that. Now horizontal asymptotes. This is also based on degree of p of x and q of x. Also, this horizontal asymptote will describe your end behavior. So they are interconnected. We have very similar root forms. Okay. So how this end behavior, so this graph to the left, it goes down. To the right, it goes up. Right? This is end behavior. Correct. Now, horizontal asymptote is a line, horizontal line, of course, horizontal line, the graph will approach. Right? And the x-intercept where it crosses x-axis, where your graph crosses x-axis. Yeah, here it crosses y-intercept where your graph crosses y-axis. So those kind of things. That is very normal. And yes, y-intercept is also we will deal with. X-intercept, we have a separate lesson for us. Okay, so end behavior, horizontal asymptotes, domain, and y-intercept. This is what we're going to do in today's video. Okay, coming to domain. Domain is, again, all real numbers except for the denominator being 0. So very simple 3 steps. Set your denominator to 0. Solve for x. You will get some values. Exclude those from the domain. So what is a domain? Domain is all real numbers. Exclude those. Okay, those values. Some x1, x2, maybe just x. Or maybe all real numbers might also work. Right? So now that is domain. Now y-intercept is very simple, where it's a point where the graph crosses the y-axis. So plug x is equal to 0 into the function and simplify to get what is y. That is your y-intercept, and y-intercept will look like 0, x will be 0 and y will have some value. Right? Now, rational functions and its end behavior, we have 3 cases. As of now, in this formula, we will come across n and m. N means degree of numerator, m means degree of denominator. So case 1, n less than m. What if your numerator having lesser degree? So this is a fixed end behavior. F of x approach 0 as x tends to minus infinity. F of x approach 0 when x tends to positive infinity. This is how it will look like. The graph is approaching x-axis. Okay, it's not exactly equal to, but yeah, it approaches. Maybe this side it will go like this. Okay, so this is what for case n numerator is less than denominator. I mean the degree. So we will have this fixed. It will tend to 0 in both the end. Now, second case, what if the degrees are equal? Here, leading coefficient of n by leading coefficient of t. That means numerator's leading coefficient divided by denominator's leading coefficient for both of them, right behavior and also for the left behavior. Okay, so n equal to m. So as x tends to infinity, f of x tends to a by b, a being leading coefficient of numerator, b being leading coefficient of denominator. Right? It will approach maybe other than y equal to, it can be 1 by 2. or 2 by 1, something like this, right? Now, what if n greater than m? No horizontal asymptote. Okay, so we will say there is an oblique or slant asymptote. And yes, here f as x tends to infinity, x tends to minus infinity. What happened to f of x? This will also approach infinity, but we are not sure. It depends on the problem whether it will approach plus infinity or minus infinity. Okay, but it won't approach any particular number. Right. So this is the case. As x tends to infinity, f of x goes to plus infinity. As x tends to minus infinity, f of x goes to minus infinity. Okay. So infinite, it will approach kind of an infinite number, right? When n greater than m. So this is case 3. And that's it. So in all the 3 cases, you can define n behavior. Also, you can define you can give a horizontal asymptote also. Okay, let's move on to first question. Let f of x equal to 2x plus 1 by x squared plus 3. What is the n behavior of the function? Okay, let me do the a part here. Numerator degree is 1. How will you find the degree, by the way? X power of x, the exponent of x, which is the biggest one. This is x, single x, right? X power, nothing means x power 1. And denominator degree is 2. This term is leading. So we got lesser, right? So lesser means what does the rule says? We have 3 rules. The first rule, lesser will go for, it's a fixed, it will approach the x-axis. Okay, so as x tends to positive infinity, as x tends to negative infinity, f of x will have the same behavior. F of x will approach 0. It's a fixed 0. That means x-axis. That is the end behavior. Now, write the equation of the horizontal asymptote. Yeah, you mean a number here, right? That is y equal to, horizontal line is always y equal to a number, and whatever we got here, we can put that. That's simple. Question 1 is over. Now, question number 2. Let f of x is x power 4 minus 3x plus 2 divided by x squared plus 1. Describe the end behavior of the function. This time I got degree of numerator being 4 and degree of denominator being 2, greater approach. That means they are greater, right? So let's go. As x tends to minus infinity, this is how we will describe, right? And as x tends to positive infinity, what happens to f of x? So f of x, if it's greater, the f of x will also approach infinity. But f of x approach minus infinity or plus infinity? That's a question. For that, you can just plug in, like we are doing minus infinity, right? Minus infinity power 4 minus 3 times minus infinity plus 2. Okay, we are not going to solve, by the way, actually. So just sign minus of any number power 4 is plus, right? A bigger number. Then again a plus. Okay, so plus plus plus, it's positive, and denominator, so for sure it's positive for anything because it's squared and added. No way of getting negative, so plus. So I will say it will approach plus infinity. It's going to be a big number, but plus big, positive bigger number or a negative bigger number. Just plug in and look for the sign. Now, as x tends to positive infinity, same infinity power 4 minus 3 times infinity plus 2 by infinity square plus 1. Denominator going to be positive. This is positive minus positive plus 2. So this is also going to be a positive one, right? Infinity power 4 minus 3 times. So you just take the number 1000, right? 1000 power 4 minus 3000 plus 2. For sure it's positive, right? So as x tends to plus infinity also, this will tends to positive infinity. Yes, if you wonder how this can be, you can quickly you take a Desmos and plug in this. You will see the end behavior. When x go to minus infinity, your graph will be moving up. Plus infinity also, it will be moving up. Right? Now, this is the end behavior, and we complete part A. Now, part B, find the values where the function is undefined. Undefined means what? Denominator not equal to 0. So x squared plus 1 equal to 0, you find it, and then that values, it will go undefined. X square equal negative 1. Okay, this is kind of an absurd. a square, if you square anything, you will get either 0 or positive. Okay, square cannot give you negative, which means this is impossible. So no real solution. I am telling impossible in our real numbers, but still, we will learn something new in our higher classes. But as of now, we have to say instead telling no solution, you have to write no real solutions. That means no need to exclude anything. It will work for any real numbers. Define for all real numbers. Okay. So no values where the function is going undefined. Okay. Now coming to C. Find the points of f of x where the graph meets y-axis. They are asking you y-intercept, right? So, okay, instead f of x, you can put y, and wherever x comes, put 0. 0 over 4 minus 3 times 0 plus 2 by 0 square plus 1. The x terms will completely get vanished. That's it. So you just divide the coefficients. So y equal to 2, and you can write a point form, x is 0, y is 2. So this is our y-intercept. That's simple. Now, question number 3. F of x is 4x cubed plus 1 by 2x cubed minus 5. Find the domain y-intercept as x increases without bond, f of x what? As x decreases without bond, f of x is what? The C and D is just another way of asking you the end behavior. As x increases without bond means x tends to positive infinity. Decreases without bond means x tends to negative infinity. That's the difference, right? Okay, coming to domain. Domain means what will you do? Set your denominator to 0, solve for x, exclude those values from real numbers. Okay, so A, 2x cube is your denominator, right? Minus 5 is 0. 2x cube is 5. X cube is 5 by 2. And your x is going to be, don't put plus or minus, only square will have the power, right? So cube, don't put plus or minus, just cube root 5 by 2. So this value I need to exclude. So domain is, you can write in set notation or a set builder form, x such that x belongs to real numbers, but x not equal to this value. This is one form. Interval notation is most common. So you have to exclude this value, minus infinity to this cube root 5 by 2. The function is working so good. Exactly at 5 by 2 it won't work. Then again from after this value it will start working. So this way also you can write. Okay. Now find y-intercept. Very simple. I'm doing it here. So 0, comma, wherever x see, you just cancel off. Okay. That will become 0. So 1 by minus 5, which is minus 1 by 5. Okay. As x increases without bound, that is x tends to infinity, what does that f of x is doing? Here we have a rule. When degree of numerator n is equal to m case we have, right? So you have to divide the leading coefficient. Okay. So that horizontal asymptote is basically y equal to 4 by 2. Leading coefficients is just divide, it's 2. So it approaches to, actually tends to, I'm writing. You can write it approaches to for both the cases. Okay. When degree is same, leading coefficient ratio, and you have to, that is what it will behave for both the cases, plus infinity and minus. That's it. We solved all 3 questions here. So I hope this might be clear. And of course, I have a bonus question too. Here we go. End behavior. Find the values where it goes undefined. Find the points where the graph means y-axis. Right? So do answer these in your comment. Do drop it in the comment section. Also, if you have any feedback, you can share it with me through the comment box again. So that's it for today. Thank you for joining. Keep practicing and keep learning. Before that, a quick reminder, if you want to join Let's Unbound student community, you can quickly scan this and join here. You will get, wait, let me place it correctly. Yeah, you can scan and join. And you will get exam updates and also save this playlist so that you will be notified with the upcoming videos. I will be meeting you in 1.8 that is also related to the rational functions. Stay curious. Let's meet in next class. That is next video.